Welcome to Study Loop.
To determine whether g of x is a probability mass function, a probability density function, or a cumulative distribution function, we need to check if it satisfies the properties of each. So, probability mass function, a PMF is used for discrete random variables and assigns probabilities to discrete outcomes. G of x is defined over a continuous range and not just at discrete points, so it's not a PMF. A probability density function must satisfy two conditions. F of x has to be greater than or equal to 0 for all x, and the total area under the curve must be 1. So the first part, it's clearly non-negative for all x, since all defined pieces are non-negative. We would need to calculate the integral of g of x over all of x. So that would be the integral from a to c of 2 times x minus a over b minus a times c minus a dx, plus the integral from c to b of 2 times b minus x over b minus a times b minus c dx, plus the integral from negative to positive infinity of 0 dx, plus the integral from b to infinity of 0 dx. For x between a and c, a included to c, the integral would be 2 over b minus a times c minus a times, it would be 2 over b minus a times a, c minus a times the integral of x minus a squared over 2 evaluated from a to c, which simplifies to c minus a over b minus a. For x between c and b included, that would be 2 over b minus a times c minus a. B minus a times b minus c times the integral from c to b of b minus x dx, which would be b minus x squared over 2 evaluated from c to b, which would be which would simplify to b minus c over b minus a. And adding these results together, we would get 1. Since both conditions are satisfied, g of x is a probability density function. If x is a random variable with PDF g of x, we can derive the CDF of x. And for x is less than a, is 0. For x is between a and c, a included, c not included, would be the integral of 0 dt plus the integral from a to x of 2 times t minus a over b minus a times c minus a dt, which would be 2 over b minus a times c minus a times the integral of t minus a squared over 2 evaluated from a to x, which would be x minus a squared over b minus a times c minus a. For x equals c, I won't write it all out, but it would would be the integral from negative infinity to a of 0 dt plus the integral from a to c of 2 times t minus a over b minus a times c minus a dt plus the integral from c to c of 2 over b minus a dt, which is equal to c minus a squared over b minus a times c minus a, which ends up being c minus a over b minus a. And finally, for x is between c not included and b included, would be the integral from negative infinity to a of 0 dt plus the integral from a to c of 2 times t minus a over b minus a times c minus a dt plus the integral from c to x of 2 times b minus t over b minus a times b minus c dt, which would be equal to c minus a squared over b minus a times c minus a plus 2 over b minus a times b minus c times the integral of bt minus t squared over 2, evaluated from c to x. And combining all of those, we would get 1. And so we get 0 x minus a squared over b minus a times c minus a, c minus a over b minus a, c minus a squared over b minus a times c minus a, plus 2 over b minus a times b minus c times bx minus x squared over 2 minus bc plus c squared over 2, and 1. For x is less than a, x is between a and c, if x is equal to c, if x is between c and b included, and if x is greater than b.